Hey everyone, this is Sightem, and in today's video we're going to be looking at a mysterious 10-year-old cheat that Rake sent me. We're going to reverse this cheat and find out exactly what it does and how it works, and we're going to recreate it at the end of the video. And along the way we're going to learn how old cheats worked back in the day. That said, let's get into the video. So since this is an older cheat, it's actually a 32-bit program. So we have it open in IDA x32, and this is DLL main. We have another jump to another DLL main, so let's follow this jump. And we have our call to create thread, right? This is all pretty typical. So we're going to follow this jump again, another thunk, let's follow it again. And here we go. So this is the very first function that the program actually executes. And we're going to reverse from the top down and figure out what it does. So let's follow this function. Let's follow this jump. Follow this jump again. And here we go. So immediately, these strings jump out to me as patterns, right? Specifically patterns that you use for pattern scanning. And we can see that this D3, D9 DLL is being passed to another function, and this UNK is being passed as another parameter. So this is probably the byte array, and this is the mask. And if you follow this jump, you're probably going to reach a pattern scan function. And we do, right? So we have this double for loop, we have this arithmetic, very typical, and we have this comparison. And I bet that if I change this to a char, we're either going to see an X or a question mark. And we see a question mark. This is great. Now let's follow this function and see what it does. So we just call get module information, right? This is all pretty typical. This is all pretty easy. So we can go ahead and rename this function to pattern scan. And if we go back, it should change the other function for us. That's great. Let's go back, and here we go. So we have two calls to this function, meaning that it's probably scanning for two distinct functions. And the result of these scans are being put in a global. So I do wonder where this first global is used. Let's do an xref, and let's go down here to this read. Click OK, and we can see that it points us to another function call that takes in another function alongside this address. Now this tells me that this is probably a function that's responsible for installing a hook, right? Maybe. Now let's go back here and actually rename this to something generic, right? Something like address1. And let's change this other one to address2 as well. So address2, and then we can go back and see what's going on. So now we are on to here. This is just a get async key state. This is probably just a toggle, and this is probably referenced somewhere else in the cheat. We're going to ignore it for now. So let's continue with this. So I'm actually going to start from this function because this is probably where the actual logic lies. So I'm going to go here, follow this jump, and immediately we see this EndScene hook detort function, or rather string. Now this tells me that this is probably a hook that gets placed on top of EndScene, and this is pretty typical stuff. It's probably just handling the setup for the cheat. And if we reverse from the top down here, this very first call to D3DX create font probably just creates a font with a interface, right? I had the documentation brought up already, and we can see that the very last function is a long pointer to the D3DX font. And if you scroll all the way down, or search for it rather, we can see that we can go here and we actually have a struct with a bunch of member variables, or other functions. So this is an interface. So I'm going to rename this to font interface. And then continuing, these are just probably loading some texture in memory, probably referenced later on in the program. So we're going to ignore them for now. Moving forward, I see this call. This is calling into this font interface at a VTable address. And if we actually change this to a decimal, we can find out exactly what this function is. We can do this by dividing 56 by 4, right? So I'm going to do 56 by 4, and this is going to give us the index of this function call. And we can actually go to Visual Studio, create a D3DX font struct, and control click on it to see its definition. So I'm going to put this here, and let's follow its definition. Can go here and can literally just count from top to down. So 1, 2, 3, all the way down to 14, which actually gives us this function, draw text A, and it actually makes sense, right? This very first function, or rather argument, is this, right? Because this is going to be the this pointer. So we have 0 passed in. I presume this is just null pointer. This is the actual string. This is the size, which is so for consistent. This is a rect, and we actually, if we go down all the way down here, this is screaming a color to me. So maybe A, R, G, and B, or maybe RGBA, and we can actually see it that it actually does take a color. So we can actually comment this and say that this is a call to draw text A. Click OK. And if this is in fact a hook function, this is a call to the original EndScene function. So I'm going to call this EndScene, or rather EndScene. And this makes A1 the actual D3D device. So let's go back here. Let's just take this name, P device, go back to IDA and rename this to P device. Because again, EndScene is a part of the device, right? It's a part of that VTable. So it takes the struct as its first variable, or rather argument. We can actually go ahead and call this HK EndScene because it's the hook that gets placed on EndScene. And this is just a variable that keeps track of this initialization because we only want to initialize this once, right? And if I do xrefs, I'm probably going to see only 2 or 3. That's that's this one, that's also this one, and that's the read to it. So I'm gonna call this init probably, or rather EndScene init. And now we can go back to the main function, go back, and here we go. So I'm curious as to what this function is about. We hypothesize that this might be a function that installs a hook. So let's see, follow this jump, and we can see an allocation. This is always a good sign. These two are the same. Let's follow it. This doesn't specifically jump out to me as anything interesting. So let's go back. That's the same one, so let's follow this, and here we go. So we see a whole bunch of things here, but one thing that jumps out to me are these two comparisons, right? We have this comparisons against 5. So this is probably the function that actually installs the hook. Now, probably somewhere within this function, we are going to be calling virtual protect. And if we follow this jump, and we can see that virtual protect is actually called here. This is just some classic this indexing, that's fine. And this class is actually using this instance of the class to actually keep track of the old protection. And we are probably going to be seeing this later on in the function. So let's actually go back to actually call this change protection, right? And then we can go back, and that's another call to the same function. Can go down here probably, and we're going to be seeing the same function call, but in reverse, right? So we're going to be restoring the old page protection. So let's follow this jump again, follow it back, and we can see that as the new protection, we're actually giving this plus 0xc, which is actually what we saw earlier on. So we're going to call this restore probably protection, and here we go. And we probably don't need to be looking at this. This is just some analysis that the function does to make sure that the instruction we're hooking isn't actually a control flow instruction. And other than that, it's actually a pretty typical trap hook x86 function. So we can actually call this maybe install hook, right? Install hook. And I think we can go back now to the main function, and let's see. So this is the, we'll call this install hook, call it J install hook, because why not? And so we have this O EndScene, that's the original EndScene, and we have another function here. If you click on 5, this actually fixes the call convention type, so that's fine. Now I'm curious as to what this function is doing, right? So we can actually follow this, and we can see that it takes 7 arguments. So let's keep following it, and we see this gargantuan if statement. Actually, we see 3 if statements, right? And if you check the cross references of this bytes, this is probably going to end up in the same main function, and it does. So this is the actual toggle of the cheat. Whatever the cheat does is probably in this function. So let's follow it again, and let's scroll through and see if anything jumps out to us. Nothing particular here. Let's keep going. Pretty much the same thing. Let's keep going again. Again, pretty much the same thing. And then there's another call to the same function. Now, we've seen this before, right? This is probably a hook on something. I just can't quite figure out what it is. So I'm going to make the assumption that this A1 is actually the D3, D9 device. And this assumption isn't necessarily based on anything. We're just going to make an assumption and take it at face value and see if we're correct. So I'm going to rename this to P device. And let's see. So if this is in fact the P device, we are indexing into its VTable and calling a function with 2 arguments. So let's actually change this to decimal and decimal again. So 2 to 8. If we take 2 to 8 and divide it by 4, 57. And I actually have the VTable of this P device already pulled up here. So we can actually just go ahead and scroll through to 57. And this is SetRenderState. So let's see if we are correct about that first assumption. Let's see if this A1 is actually the P device. So I have the MSDN of Direct3D device 9 pulled up, and let's go to SetRenderState, right? SetRenderState, right? That's here. And let's see what it can do. So it takes a state and a value. So let's check what the states can be. So if you scroll down here, this very first one is Z enable, and it's actually set to 7, right? This is an enum. So if we go back to IDA, you can actually see that this very first argument is set to 7 and the second one is set to 0. So what does this Z enable do exactly? Let's scroll all the way down, and we can actually see that it's in charge of setting the depth buffer for the current device. And so anything that's within the device, if this state is set to false for it, it's going to be rendered on top of everything else. That's essentially what Z-buffering is. Now, when would you want this forced? Well, probably when you have some form of a wall hack, right? Or chams, or something related to ESP. So you can see all the enemies through walls. And it says that D3DZB false, or it can be D3DZB true. And if you actually take this, go back to Visual Studio and paste it in our main function and follow its definition, you'll probably see that it's set to 0, and it indeed is. And so we can see that this is the actual state, and this is the state it's being set to. It's 0. So we can actually set a comment here, right? And we can do SetRenderState, and we can go back to MSDN, go back here, and we can do probably Z enable. Take this, put it here, fix it up, and 0. Click OK. And this is another function, right? This is the same function as before. It's actually setting 8. So let's actually see what 8 is all about. 8 is fill mode. Oh, so it's probably some form of a Chams fill, maybe. That's what is jumping out to me as. But let's keep going. So this 260, we can actually take this and divide this by 4 again. We get 65, and if you go back to this and scroll all the way down, 65, we can set texture. And earlier on, we saw a bunch of functions that were loading a texture from memory. And I bet you that if we do a cross-reference on this, we are going to be ending up in the same function, and we are this HK EndScene, and we're actually right here. So this is a texture that's being loaded into memory. So maybe this is some form of a textured Chams, maybe? Not quite sure yet, but let's keep going. And so then I see this call to that original function. So it's taking a P device, which is probably just a call convention, and then it's taking 6 other arguments. Now we can actually narrow down this function quite easily because there aren't many functions in this VTable that take 6 variables. So we can go back to Visual Studio, main, Control Z, and actually want to change this to the device. So let's go back here, take this device, iDevice, click on it again. And we can see that there's a whole bunch of functions here. Now, for the sake of not making this into a 3-hour long video, I've actually already counted these arguments, and the function that we're particularly looking for is called draw indexed primitive. Now, if you're familiar with these kind of ESPs, this is actually pretty typical. And if you actually look up what it does on MSDN, we can see that based on indexing, renders the specified geometric primitive into an array of vertices. And this is a pretty low level function. This is how everything is rendered within the game. And there's a bunch of clues in this code that I should give this away. So first things first, I'm going to change this to a decimal and also this to a decimal. So if you're correct about this, A5 is going to be number of vertices and A7 is going to be prim count. The checks that are comparing A5 and A7 appear to be correlated somehow, because usually prim count, or A7, is consistently larger than its number of vertices. And if you actually change this to decimal, you can see that this is a trend throughout this function. And it makes sense because in index geometry, you have X vertices, but you draw Y triangles using them. So this is always going to be larger than this number. And the fact that we are modifying the state of this render using SetRenderState is actually a clue as to, well, maybe we are implementing effects like drawing through walls, right? Because we are disabling the Z buffering. And again, when would you want to do that? When you want to have a Chams hack or a wall hack, right? So I'm pretty confident that this is in fact the original draw index primitive function. So I'm going to rename this to O draw indexed primitive. And I'm going to rename this to HK draw indexed primitive. And so we're going to rename each of these one by one. So let's actually go back here and we're going to start from the very end. So prim count, A7, and paste. And here we go. Now, we have figured out what it does. This is a Chams hack, but we don't quite know what game it's for. That's kind of the question we haven't really answered yet, because this seems like a very generic D3, D9 kind of hack. This could be for any game, and as long as that game has these number of vertices or has objects with these number of vertices and triangles, right? We're going to have some form of Chams. So let's actually take this to GitHub and see what we can find there. So I have GitHub brought up already. Let's do a search for this string, and we're going to do search. And we're going to go to code, and there we go, right? We can see this css.h file, we can see this css chams file. So we are correct about the chams. Now CSS is, I believe, going to be Counter-Strike source. And if you actually look at this file, we're actually going to be presented with the same thing that we saw earlier. So if you actually take this line, Control C, Control V, and that's it. And these are for the terrorist and the anti-terrorist. So the game is Counter-Strike Source, which is great. We just answered another question. And we could do this because Source is a pretty well-known game and it's been reversed many times in the past and there's been many cheats made for it, right? So that's why we can do this. Now, if we go back to the cheat, we can actually rename this to, let's just rename this to enable, right? And we can actually go back to the main function, I imagine, and we can see that we've basically reversed almost everything except this, which is the pattern scan application. So I'm actually going to call this setup. And if you go back here, it should be JSetup, which is fine. Yep. And here we go. So we have a hook on EndScene and we have a hook on draw index primitive, and that's the actual hack. And as far as simple goes, this is actually a pretty simple cheat, right? We have just 2 hooks. We have a pattern scan right here, and that's pretty much it. And that's really as easy as it can get. So with this information in mind, we can actually go back to Visual Studio and start remaking this cheat from scratch. So I've gone ahead and set up a new project with Minhook, and that's what we're going to be using for this video. If you don't know what Minhook is or how to set it up, we have an excellent article on Minhook specifically. And as always, it's going to be linked in the description below. I've also gone ahead and typedef the functions that we know we are going to be hooking. So we have two typedefs, one for EndScene and one for drawIndexPrimitive. I've also gone ahead and included these functions directly from the website. These are just basic pattern scan functions that we know we're going to be using in this video. And since we've already explained these functions in detail in previous videos and tutorials, I'm not going to get into them. As a matter of fact, we aren't going to be touching these at all, and for that reason, I'm going to be collapsing these functions entirely. With that said, we can go ahead and start writing our initHook function. So first of all, we're going to start calling minhook initialize, right? So image initialize, like so. And now we need to start thinking about pattern scanning for the functions that we know the cheat was hooking. So when I was researching this video, it occurred to me that both of these functions are a part of this interface. And this interface is essentially just a VTable. And so I figured if we just find the address of the VTable, we can just index into the VTable and have access to all the functions we're going to need. And I happened to come across this excellent answer by Borian. As always, all the questions you may have already been answered probably more than once on the website. All it takes is just some looking around and that's it. So basically what we're going to be doing is we're going to be looking for a constructor function for this interface, right? And we're going to be using this byte pattern to scan for this function. What we're going to need to look out for is that obviously these two bytes aren't interesting, right? Because they're just the move instructions, as he says. So we need to shift whatever we find by 2 because that'll give us the actual address of the VTable. So with that said, I'm just going to go ahead and copy this string and we're going to be using it directly in our cheat. So let's do const char pointer pattern equal to that. And we're also going to need a mask, right? So we're going to do const char pointer mask equal to basically XX and then question mark, question mark, question mark, XX, question mark, question mark, question mark, question mark. This time we need 4 because we have 0, 0, 0, and 0. And then we're going to do XX again. And obviously we're going to use these two to call our find pattern function. So now we can go ahead and declare a new uint pointer, right? So we can do uint pointer t equal to constructor address, right? Constructor address equal to find pattern. And then we're going to call this function with the d3d9.dll because that's where the constructor actually lives, right? And we're going to pass it pattern and mask. Simple. Now we basically need to do what Brian said we need to do. We need to shift whatever address we get by 2. So we can declare another uint pointer t VTable pointer, and then we basically set it equal to constructor address plus 2, but we want to dereference this address. So we do dereference, and then we want to dereference it into a uint pointer t. So just so the compiler doesn't complain, we're going to cast this to a uint pointer t before we cast it, or rather a uint pointer t pointer. So now that we have the VTable, we can go ahead and index into this VTable and look for EndScene address and drawIndexPrimitive. So let's do uint pointer t again, this time EndScene equal to, and basically EndScene is at the 42nd index of this VTable. You can find a complete list of all the indices of the functions in this VTable in the description below as always. And that's basically how we know the offset. So we essentially want to do VTable pointer plus 42, but obviously this isn't going to work. We're going to have to multiply this by the size of, right? Size of white pointer, and we need to do this first, right? So let's just put it there just to be explicit. And then we need to cast this entire thing to a uint pointer t and then dereference it, right? So uint pointer t, let's do a cast right there, and let's do the reference. And this will basically give us the address of EndScene, right? This is what we're going to be using in our call to minhook. Now, we can go ahead and do the exact same thing with drawIndexPrimitive. So uint pointer t, drawIndexPrimitive equal to, and now this time we want to go to offset 82, right? So we're basically going to do VTable plus 82, but then obviously we're going to have the same exact thing, right? So we're going to multiply by the size of white pointer, put it in parentheses just to be explicit, and then we want to cast this entire thing again to a uint pointer t and then dereference. So I have that, and let's do that too. So add those parentheses just like that. And now we want to actually call minhook create hook. And now what we want to do is we actually want to call mh create hook. So we're going to do mh underline create hook, and then we're going to give it the address of EndScene, right, as a long pointer void. And then this is going to be the address of our hook that we're going to write later. And as always, we're going to need some original function to keep the actual original inside. So we can go ahead and define that as a global, right? So EndScene EndScene, let's call it EndScene original, right? Original, orig, and we can basically give it the address as a pointer to a long pointer, right? So LP void pointer. And that's basically it. And we basically want to repeat this exact same thing, but for draw index primitive. So I'm just going to go ahead and copy and paste this function again. Copy draw index primitive address here and call this draw index primitive hook. And I'm just going to copy this and go here and do draw index primitive original. Then we can go ahead and declare a new global variable. So I'm just going to take that and put it in a global scope. And I'm going to take the name up here and paste it right there. And there we go. So now we can start working on writing the actual hooks. The first one I'm going to write is going to be the hook on EndScene. So what we can do is that we can basically just do h result and then standard call to EndScene hook, take it right from here, paste it in. And we know that this function takes some p device, right? So we can just take it from up here and paste it in the parameter list. And now we need to recall what the function was doing in the original hook. And basically what it was doing was that it was calling some init function that used d3dx create font to create some font object to then use that font object to draw some text on the screen. And that's exactly what we're going to do. So first let's go ahead and define a new boolean called gbinit. And basically what this function will do is that it'll make sure that we only call that initialization function once, just like the cheat. So now we can go ahead and do if gbinit, right? Or we can just copy it and paste it here and negate it. And basically just do a call to d3dx create font a. And you can do anything you want here. This is just the most basic way that I'm just using to demonstrate this concept to you. So let's do d3dx create font. Let's see, create font a. And basically it takes a couple of parameters, right? So we're going to do p device, and then we're going to give it 15, 0, and probably FW bold because we want it to be bold, 1 and 0. We wanted to use the default character set. So let's do default, let's see, char set. And we wanted to use the default precision. So out default precision. We want it to be anti-aliased, right? So anti-alias quality. We want it to be default pitch. Let's see, default pitch. And FF don't care. We want to draw it as Arial because we also want to draw it as Arial because that's what the cheat was doing. And as the very last parameter, it's going to be expecting some font object. So we can go ahead and create another global variable here, and it's going to be of type I d3dx font. So I d3dx font, let's see, d3dx font. These have to be lowercase, obviously. And we're going to make it a pointer to some g_p font. Go ahead and set this to null pointer. And now we can go ahead and complete this call and be done with it, right? So let's just paste this in, and here we go. Pass the address, and there we are. And at the end of this, we're going to want to set gbinit to true because we've initialized the font and everything's fine. Now in your own code, you want to check the return value of this using the failed macro. If you just go on MSDN, these are all documented. Every single one of these arguments have all been documented. And as I said, what you do here is completely up to you. This is just for a visual presentation and nothing more. So now that we have this GP font, we can go ahead and actually draw the text. So we can start off by writing an if statement. And basically, we want to use draw text just like how the cheat was doing it. And to call draw text, you're going to need to specify some rect struct. So I'm going to define a rect called rect and set it equal to these values. So 10, 250. So now we can go ahead and take GP font and call draw text on it, right? So GP font, dereference, draw text. You can either do draw text A or draw text W or just draw text, but preferably you want to do draw text. And now we're going to call it with null and the string we want to draw. So we're just going to do direct x hook active. And then we're going to specify -1. And basically what this will do is that it'll make the function calculate the size of this string. You can also provide the size manually. And then we're going to go ahead and give it the address of this rect. So paste it right here, address of. And we want to specify dt noclip and dt left. So dt_left. And let's say we want to make it green. To do that, we can use the d3d color argb macro. So d3d color, and it should pop up. So color_argb, and we can give it the following values. So 255, 255, 0, and 0. And that's basically it. And now, just as you would with any other hook, you want to call the original function. So return EndScene, actually you can just take it from here, and p device, because that's the original function and that's what it takes. If you scroll down now, we can see that this function call is now complete and nothing is complaining about anything, so we are probably going to be okay. Now we can go ahead and start working on the draw index primitive hook. Since this is a lengthy function, I've gone ahead and typed it out already, so I don't have to watch me type out these arguments, just to save time. So the actual cheat, as you may recall, had these massive if statements, right? And basically what I've done is that I've gone ahead and created two very nice macros out of them. This is just the first if statement and this is just the second one. And basically what this will do is that this will expand to those massive if statements so that we don't have to write them manually. And you'll see exactly how to use these in just a second. Let's go ahead back to our main file and include this header. So let's do #include macro.h. Go back down here and let's start writing the filters. And essentially this is what we're going to be doing. We're going to be calling get render state and then set render state with the proper values. And then we want to call the original function and then we want to restore the render states that we just stole. So we can go ahead and make a new dboard called dboard old and set it to d3dzb_true. And now we can go ahead and call get render state on this p device. So we can do get render state just like that. And we want to get the state of d3drsz enabled, right? So d3drs_z enable. And we want to give it the address of old. So let's just do this, and here we go. And now what we want to do is we basically want to do the same exact thing, but with set render state. So we can go down here and do p device. Instead of get, we're going to do set render state. The z enable is basically going to disable the z buffering, which is basically what's going to give us wall hacks. And we're going to set this to d3dzb false. Now, if you're wondering where these values are coming from, this is exactly what the cheat was doing. So if you recall, the set render state call in the actual cheat was calling it with 7 and 0. If we go ahead and click on these, we can go ahead and see that d3dzip false is defined to false. And if we go back here and click on d3drsz enable, we can see that it's defined to 7. And this is exactly what we saw. These two are both completely and fully documented. So we aren't doing anything particularly special here. So we've done the set render state. Let's go ahead and move these comments so it's less confusing. I'm just going to put this here and here. So now we want to call this original function, right? So draw index primitive original, take this and paste it right down here. And we want to pass it all of these values. So I'm just going to take these and paste them here. And then we can go ahead and clean these up like so, right? So we're just going to clean up the types like that. And here we are. Now, if you really want to, you can set this to a result called hResult results and set it equal to this. And then what this will let you do is basically you can do error checking on the return value of this function. And you should be doing that in your actual cheat. And now we can go ahead and set render state again, but with this old variable. So we can just do this and give it old instead of d3dz be false. Now for our own team, let's do else if. This time we're going to do anti-terror, right? So anti-terror, and here we go. The code is exactly the same. We can literally take this entire code and paste it right down here, right? And this will give us wall hacks on both our teammates and the enemy team. Now, the original cheat was applying a texture on top of these models too, but we are not doing that here. We are just setting the z buffering to false. And then if you're really worried, although it's never going to happen, you can just do return and call the original function here as well, just to be sure. And now we can see that this second function call is now fully working and everything's completely fine. And now we have to actually go ahead and enable the hooks using mh enable hook. So mh enable hook. And we basically want to give it mh all hooks, right? Mh all hooks, just like that. And let's go ahead and return true just to be safe. And here we go. This is basically the most basic chams you could possibly get. So we pattern scan for the VTable of these functions, and then we index into these VTables using their indices, and then we install these two hooks onto them. And these hooks are pretty similar to what the actual cheat was doing. And yeah, now we can go ahead and compile this program and go ahead and test it in game. So I've gone ahead and launched the game through Steam, and if we go ahead and click inject with this file selected, we can see that our hook indeed gets activated. So, and if we do create server and do start, this is just going to be a bot lobby and wait for it to load. We can see that once we're in game, we can actually see our teammates through walls, right? And this is exactly what we expected to see. Now you might notice that there's some glitching going on here, and this is because the actual game does some queuing on these models, because you don't want to be rendering the models all the time because that's inefficient. And that's exactly what's going on here. This actually doesn't have anything to do with our cheat. This is just the game engine. The actual cheat does nothing to actually mitigate this, but newer cheats do actually have mitigations against this, but that is beyond the scope of this video. And with that said, we can go ahead and conclude this video. And yeah,